is a joint project with Matt Jackson. And our motivation is the innocuous observation that groups often make intertemporal decisions collectively. So just to mention a bunch of examples, you can think of political committees, you can think of firms and management teams and firms. You can think about households. That's an example that I'll come back to in a minute. You can think about multiple motives in one's own mind as a situation in which there is a group of some things that make a decision collectively. Now, we know if you've taken a class in political science or in social choice, you would have heard about impossibility theorems. So there are many out there that illustrate that there is a difficulty in aggregating a bunch of preferences. So going back to Arrow, then there are a bunch of things by Plott and McKelvey that look at the problems that majority voting may induce, and there are some even issues of aggregation of posteriors. So there's a literature that asks similar questions in the realm of updating. I'm not going to talk much about that today. So the main question that we're going to ask is what happens if the alternatives are time sequences of consumption and agents discount sums of utilities of consumption. So we're going to look at a very particular case of time discounting and ask whether it's amenable to aggregation. So we want to know whether society can aggregate preferences in a quote-unquote rational manner, by which I mean time consistent and transitive. Now, in general, there are two desiderata on group decision-making which correspond to time consistency and transitivity. And the reason is that time consistency, for example, is a cool thing because it ensures that decisions stand up over time without any costly commitment instruments. So it's really nice. It's also very nice technically because we can use all sorts of recursive methods when we solve our models. But that's more a theoretical reason why we like these sorts of models. Transitivity is a really nice thing to have because it ensures that the process is well defined and will not cycle endlessly or be subject to manipulation. Now let me give you some motivation for why we think different discount factor might actually be a relevant thing to have in mind. So I'm going to use the example of a household, but this is going to be relevant, we think, for a variety of other situations, including a political setting in which you have different political actors who have different time preferences. But in the case of a household, think about a heterosexual household. If we look at the UN statistics, for children who are born between 2010 and 2015, there is a wedge between the life expectancies of males and females. So, for example, in the US, the life expectancies of females is 82. For males, it's 78. France, 85 for females, 79 for male, and so on. It's pretty much across the board. So, guys, drink up your wine because life is short. What? Something weird happened?
Usually it was something that goes in this direction.
Sorry? I don't know what happened. What just happened? It's refusing. No, it doesn't work. Life has just become even shorter.
We have a bunch of years to
Let's go at the same history.
Okay.
Does it work now when you move it around? Yeah.
Great. Okay. In addition to that, so not only is the life expectancy longer for males as opposed to females, but also if you look at the marriage age, when people marry, the guy tends to be older, at least in the Western world. So, for example, in the U.S., the average difference is a bit over 2 years. So, combining these two effects, there are different estimates on how much longer a wife would live relative to her husband. So, for example, Browning estimated for Canada that a woman of the age of 65 will have an expectancy which is 50% longer than her a male counterpart. So this would suggest that different time preferences within the household, just because the life expectancy is quite different. And like I said, we think this is relevant for many other groups in which collective decisions occur over things, over intertemporal decisions. Another perspective is just thinking about different motives in your own mind, kind of how you balance out different motives when it has to do with decisions that occur over time. So let me go briefly over other related literature. The literature on time inconsistency is vast. There's no hope for me to go over it, but I'd just like to highlight some things that have been done. So on time inconsistencies, there is a wide variety of studies that either illustrates time inconsistency using field or lab experiments, or tries to model it. So let me give you one example of a classical experiment that I'll go back to as I go through the talk. And I'm not going to defend this experiment. It's plagued with problems. I just want to give you a flavor of what these experiments look like. So one of the classical examples is by Ainsley and Hanslem. And what they did is posed a hypothetical question to students and asked them whether they prefer a $100 certified check today as opposed to $200 checks cashable in 2 years, or they just delayed the entire thing by 6 years. So what they saw is that the majority of individuals preferred the $100 certified check today as opposed to the $200 check in 2 years, but they prefer $200 check in 8 years to $100 check in 6 years. Okay? So this is a problem for our standard discounted utility model, because this would suggest that the utility, the instantaneous utility you get from 100 is greater than whatever the annual discount rate delta is squared times your instantaneous utility of 200. But when we multiply both sides by delta to the 6, suddenly the inequality reverses. So this is a problem. There are also a bunch of experiments on intransitivity. So intransitivity is not only a theoretical construct, it also is something we see in the lab with a variety of creatures. And the last strand of literature that I want to mention is that of models that have to do with multiple selves. So there's a recent mushrooming of papers that have to do with kind of thinking about what would happen specifically when there are different individuals who are within oneself who are making a decision. So there is some relation theoretically between what we're doing and this literature. Okay, so I'm going to go straight into the model unless there are questions. Yes?
I can start on the literature thing. I mean, the one thing I know about this is the volume measure papers. Is that the same?
It's not going to be the same thing because we're going to look at a given population of agents with given discount factors. So the preferences in some sense will be fixed, and then we'll look at how to aggregate them. So there's kind of a spiritual connection, but I'm not sure there's a technical one.
That bit of a choice of investment streams.
Right. But as I go through the model, it might become clear. Okay, so the agents are 1 through n, and the real atom of consideration that we'll think about is a consumption stream. So a consumption stream is a vector of consumption. This is the C, and it just identifies daily consumption, C1, C2, C3, and so on. I'm going to look at infinite streams just because it's going to be convenient to present this. Nothing would change if I looked at finite streams, so our results don't hinge on that. Agent I evaluates consumption in a standard way. So they have a discount factor and an instantaneous utility, and they basically calculate the net present value. Okay? Just like we do in Econ 101. Now, I'm going to assume that the instantaneous utility is well behaved. This can be relaxed as well, but for now I'm going to assume that it's twice continuously differentiable, strictly increasing, nicely behaved. And agents evaluate a common stream of consumption. So this is going to be the crucial thing. So what identifies here a group of individuals is that they have to decide together on the stream of consumption. So this is going to be common to everyone. So common stream of consumption, again, we have these net present values that correspond to each of the 1 through n individuals. Each individual is identified by a discount factor and an instantaneous utility. We want to know how to aggregate these. Now, when you talk about collective decisions, there are two ways to write this up. So this is completely techie. Mostly I'll think about a collective utility function. So basically it identifies for any profile of preferences, namely this profile of discount factors and instantaneous utility, there is an aggregate collective utility function that associates a number to any consumption stream. A different way to look at the problem is to think about a preference relation. And for most of the talk today, maybe depending on time, it might be all of the talk today, that's what I'll focus on, the collective utility function. Okay, so just to give you examples, I'm doing this just to make sure that the underlying notation is clear. You can think about a weighted utilitarian collective utility. So that just means that you put different weights on different individuals and you sum up their net present values. Okay? You could also think about a max-min utility, where you're basically maximizing a consumption stream that assures that the minimum across the individuals is good. Okay? So these are examples of utilities. So does the underlying setting kind of make sense? Okay. All right. So the outline is going to be as follows. I'm going to start with a simple, if not simplistic, example of utilitarian aggregation and try to show you that this inherently entails present bias. So the types of biases that are common in the literature are going to appear just out of utilitarian aggregation of different time preferences. Then I'll move on to the general aggregation of utilities. So we'll try to look at a general method, not necessarily utilitarian, of aggregating preferences. And what I'll try to show you is that it must be time inconsistent. So in some sense, time inconsistency is inherent to collective decisions when the individuals differ in their time preferences. If I have time, I'll talk a bit about voting over time streams. I'm not sure I'll have time, but if I do, then I'll show you that this is cursed with a different problem of intransitivity. Okay, so let's start with utilitarian aggregation. So like I mentioned before, utilitarian aggregation just means that you have some weights over individuals, either because you care about them more or because they have a different mass in the population. And you are just weighting the net present values. These are these big U's, okay, that hide in them already the personal discount factors and the instantaneous utilities. What do we know? Well, there's actually, interestingly, a very old literature that's more verbal by Marglin and Feldstein that actually noticed that if you're aggregating different time preferences, you may hit problems. So we were sort of impressed with these guys who didn't have a model in their hands but still understood that there might be a problem. And we want to understand whether there's some sort of general insight here. So let me start with the silliest example one can think of, and it's going to emulate this classical Ainsley and Hanslem example that I just showed you. Okay? So think about two agents, Constantine and Patience. So Constantine has a discount factor of 0.5, and Patience is more patient and has a discount factor of 0.8. And let's think about a situation where they're comparing two consumption streams, C and C prime. C entails 10 utils today and 0 forevermore, and C prime entails the higher price tomorrow. Okay? The higher price of 15 utils tomorrow, 0 any other time. So let's calculate net present values. So if we put a weight of 1/2 on Constantine and Patience and calculate the utilitarian welfare, then when you look at C, both agents get 10 utils immediately. So each one of them gets 10 utils. So it's just the average of 10 between two people, that's 10. If you look at C prime, then Constantine discounts 15 by 0.5, Patience discounts 15 by 0.8, and if you do the algebra, you get 9.75. So they prefer the immediate lower reward to the delayed higher reward. Now notice that the Constantine has a strong preference for the immediate reward as opposed to the delayed reward, while patience is patient. So she, by herself, would prefer the delayed greater reward. Okay? But when you sum them up, it turns out that they actually prefer the immediate smaller reward. Okay, now let's do the Ainsley and Hanslem exercise and just shift the consumption streams by one period. Okay, so it's the same consumption stream. All I did is stick a 0 in period 1. Okay, so now they're comparing 10 periods tomorrow or 15 periods in 2 days from now. So now let's do the same sort of math. So when we look at the welfare from C, now we're weighting 0.5 times 10, the value of Constantine, and 0.8 times 10, the value of patience at 6.5. And for C prime, we need to weigh 15 with the discount factor squared, because now it's 2 periods from now. Okay? If you do the algebra, you get 6.675. So now it's reversed. Okay? So this is precisely the Ainsley and Hanslem experiment. Now notice that the individuals themselves are completely consistent. So the preference of Constantine still prefers the earlier, smaller reward, and patience still prefers to wait. So they're completely consistent. But when you do the welfare, you get this reversal. Let me skip this. Okay, so...
The 1% approach, this would be in the sense, it would be an analog better than
Exactly. Yeah, and in fact, if you looked, I won't go through the details for time, but if you looked at the population with uniform discount factors, you'd get precisely the hyperbolic discounting, even the functional form. Okay. So, but let's see if this is general kind of for whatever distribution. So I'm just going to make this simple point now. So I'm going to define present bias as we read it from all the experiments we've seen. I'm going to say it now in words. For those of you who feel more comfortable with the formula, there's one above the words that I'm going to say. So present bias essentially entails two conditions. The first one is that there are some cases where one becomes more patient as decisions move toward the future. Okay? So this is the first part. So sometimes you may become more patient as you move to the future, but never the reverse, which means if anything, you always become more patient, you never become more impatient in the future. Okay? That's present bias. So the first proposition that I want to show you is that if V is a utilitarian aggregation utility with positive weights on some agents who have different discount factors, then V is necessarily present biased. Okay. Yes.
So are you assuming that preferences are separable, your discount factor in time? Like, is this? I mean, in theory, the individual preference may.
Yeah, so we started, it's a good question. So the question, just for those who didn't hear, is whether how we restrict the individual preferences. So we're sticking here to preferences that are time consistent. And the exercise is really to show that even if you start with individuals who obey all the standard assumptions, the aggregation itself is going to get you the time inconsistencies. Now, naturally, if you started out with individuals who...
The question was simpler. I understand the inconsistency.
Yes.
I'm just saying, are you assuming that it's separable over time, the individual preference, or it doesn't matter?
Well, in particular, they are separable because they're time-discounted utilities.
Time-discounted, yeah.
Yes.
You're assuming that.
Yes, we're assuming even more. We're assuming that they're time-discounted. Yes, we may, but naturally, if we relax the utilities of the individuals, we're going to get the time inconsistency in an even easier fashion. So what I'm going to show you is that even if you restrict the agent's utilities to be not only time separable, but time consistent, it's still going to be a problem to aggregate them in a time consistent fashion. Yes?
So one of the assumptions we make is that the weights are the same no matter what problems you're considering. Whereas, like, if you are reading the social planner, you would probably aggregate welfare or a very patient and a very impatient, like we're going to die tomorrow. Like, probably if you compare it to something 100 years from now, you probably it's very little.
Right. So notice the quantifiers here. So the quantifiers are give me a set of discount factors, give me any set of weights, okay? then it's going to be present biased. So it might be that for different problems you use different weights, but the exercise is for a given profile of discount factors. Okay, so the implications are that utilitarian planners, be it within oneself or for a collective, will necessarily be present biased. That's almost rereading the proposition. Also, I want to kind of mention as a comment that from an econometric point of view, these sorts of results suggest that looking at an average of discounts in the population is of delta i's to the t is naturally not like looking at the average of the discount factor and that thing to the power of t. And therefore, if you're just averaging over the population and assuming that they come from an identical discount factor, you might get estimations that look as if people are time inconsistent. Yeah.
To clarify what it means to have just any positive weights in utilitarian, so is that the same as assuming equal weights but allowing any distribution of...
Yes, yes, exactly, yes. And Francesco? Yes.
Yeah, so as well as equal weights utilitarian, I mean, did you think about the ways to aggregate?
Yes, I'm going to get to it. This is a glorified motivating example. Yes. Okay, now let me give you a brief intuition in case it wasn't clear from the example. So just the intuition for this very simple result is that suppose that you have a population with a sequence of discount factors, delta 1 through delta n, where delta 1 is the smallest, delta 2 is bigger, etc. Now we think about the corresponding discount factor in the utilitarian welfare function. So the instantaneous utility of the consumption at time t is going to be discounted with this weighted sum of the delta i's to the t. Now notice that from calculus we know that this tends to, as t goes to infinity, this is going to approach wn delta n to the t, the highest discount factor, right? So this means that as you go to higher and higher t's, you're giving more and more influence to the most patient person. Okay? So this would suggest precisely this present bias. As you move forward in time, you're putting more and more weight on the most patient person. Okay? And this is what's driving this result.
But in some sense, this goes back to my question before. I mean, it's quite important the way you're discounting these preferences. You might have time consistency at the individual level, still not having this property that, say, the individual intertemporal rate of substitution is constant, or things like that.
I'm not sure I understand. So the exercise is to say, take this extreme case. If the individuals were not time consistent in and of themselves, it wouldn't be very surprising that when you aggregate, you get time inconsistency.
Do you get present bias?
Do you get present bias with other?
Right.
That I don't know. That I don't know. So you can come up with more general conditions for when you would get.
You can have time consistency at the individual level, but with more general.
Right, absolutely. This is just a motivating examples for what types of problems you may face when you're aggregating decisions, even by time-consistent individuals. Yeah, but you're absolutely right. One could generalize this to think about when you would get present bias in general. Yeah. Yes. Okay. All right. So this was the kind of the simple case, and now I want to move to our general focus, which is the general aggregation of utilities. So in particular, we want to understand whether this is basically Francesco's question, is there some other method, not necessarily utilitarian, that will be time consistent? So is there a way to get around that problem? In particular, you can think about a bunch of best-selling hits from our literature, like min-max, some order statistics, measure of inequality of utilities, what have you. And we want to understand whether we can pick something that would get us to time consistency. Okay, so first of all, let me define precisely what we mean by time consistency. And this is essentially not our definition. This goes back to Koopmans from 1960. So this is the original definition of time consistency. And the original definition of time consistency entails two restrictions. One is a stationarity restriction. It basically says that if you just shift consumption by one period and stick the same consumption in period 1, the C1, nothing changes in your preferences. Okay, so this is the first restriction. Now I need one little piece of notation. I apologize for more notation. But this just means C bar C prime just means that you append the elements from C prime after the T elements from C. Okay. So the second restriction is sort of an independence restriction, which just says that if you have some block, if you're comparing two streams that have a common block of consumption, your preference over these two streams doesn't depend on what occurs in this identical block. Okay? So whether it's stuff that's taken from C double prime or stuff that's taken from C triple prime, doesn't matter. Okay? So this is, in a sense, independence. If they're both fixed, it doesn't matter what happens there. It's independent of what's happening there. Does this make sense? Okay. Now, the second condition that we're going to require is unanimity, which is essentially Pareto efficiency. So what we're going to require collective utility is that if everyone in the population prefers C to C prime, then it better be the case that the collective utility also prefers C to C prime. Okay? This is what we call unanimity. Okay. So consider you a profile of preferences. This is this profile of discount factors and instantaneous utilities, such that each agent has a different discount factor. Okay? Then a theorem says if a collective utility function is time consistent and satisfies unanimity, then it is dictatorial. That is, there exists some agent I with such that up to an affine transformation, the collective utility just mimics this guy's utility. Okay? Yeah?
Is this also fixing the discount factors, so you're only considering the C's?
Yeah, so we exactly. So we're considering a profile U. Given a profile U, we're asking, yeah. Yes?
Why must it be an affine transformation rather than a elemental transformation?
Rather than?
A elemental transformation.
That's just the utility representation theorem. I'm not sure I fully know. Yeah. Okay, so yeah.
Is that actually true on infinite streams?
That is for infinite streams.
So it's dictatorial. So often in infinite streams you get these limiting things like multifilter structures. So you don't get actual dictatorship. You don't get.
No, so here everything I say is for infinite streams. Now soon I'll give you the intuition of the proof and you'll see that it's not necessary for it to be infinite, but this is for infinite. Okay, so the first step is sort of not even ours. It's taken from Koopman's, which says that time consistency effectively implies that the quote-unquote social planner uses a discounted utility, a standard time discounted utility. So there is some discount factor and some instantaneous utility that characterize the social planner's utility. Okay. So our exercise is really to show that these discount factor and the instantaneous utility coincide with one of the agents' discount utility and instantaneous utility. So time consistency has very powerful implications on the functional form. This is not our insight. This is Koopman's beautiful insight. So that's the first step. So really the crucial step in the proof of this theorem is illustrating that this is going to coincide with one of the agent's preferences. And now I'm going to give you a hand-waving intuition for why this is the case. So let's assume, allow me the freedom to assume that we've already shown that the instantaneous utilities coincide with someone utility. And in fact, let's even assume that all of the agents have the same instantaneous utility. The real focus here is on time preferences, so this is why I choose this intuition to give you, because I really want to show you the crux that comes from the different discounts. Okay? So we're assuming that the collective instantaneous utility coincides with everyone's individual instantaneous utility. And now I'd like to show you that the discount factor must coincide with someone's discount factor. Okay? So suppose that it doesn't, and that all the discount factors are different. Then notice that if you look at these vectors of discounts, the 1, delta 1, delta 1, delta 1 squared, delta 1 to the third, etc., go over all of the individuals as well as the social planner who has a different discount factor, they're all linearly independent. Right. So now let's write a system of linear inequalities where we're going to choose C and C prime such that in the first inequalities, we're going to think about this as a number. So these are kind of linear inequalities in these coefficients. These are the coefficients. And the first inequalities correspond to each of the individuals 1 through n. And they just require that essentially each agent I prefers C to C prime. Okay? Now the last inequality has just this, is the same sort of inequality, but just reversed. Okay? Now, since they're linearly independent, we can find some parameters here that will satisfy them. Right? Once we found such C and C prime, this suggests that the agents prefer C to C prime, but the social planners prefer C prime to C. And this precisely contradicts unanimity. So this just gives you a sense of where kind of unanimity has a bite in this setting. Now, I should mention that this is actually really a hand-waving intuition, so the proof doesn't go that way. I'm using this just for the presentation because we do indeed need to show that the instantaneous utilities coincide, and as it turns out, that complicates life a bit, so the proof is completely different. But it does use consumption variation on 3 periods. So in fact, even if as long as you looked at a problem with 3 or more periods, and time inconsistency is interesting only for cases in which you have at least 3 periods, this sort of argument would go through. So it's not, it holds for an infinite stream, but it could hold for shorter streams. And for those of you who are kind of entrenched also in the experimental literature, you may know that recently there has been some new experiments that show that in very, very simple restricted settings, we don't see time inconsistency in the lab. And this is in a way a method to bridge the different literatures out there. So it might be the case that when you kind of elicit a particular dimension of decisions, which is very simple, you'll get time consistency, but in more complex decisions that involve aggregation of different motives, you'll see time inconsistency. So, and this is one way to read kind of the contrast between these different types of more empirical literatures. Okay. How am I doing on time? 12 minutes, okay. So let me just mention briefly what happens if you relax the time consistency. So, and this is a kind of a different take of relaxation of preferences that's different than what Marco was asking. But one way to think about collective, maybe it goes a little bit to kind of the questions about relaxation that Georgi was asking before. What if you didn't require time consistency? What if you thought the time consistency is too strong for the collective utility, you just wanted separability? Okay, so here we're still sticking to separability, but we're allowing discount factors to be as funky as you want, to depend on time. Okay? As it turns out, if a collective utility function of the form, of this form, where you put some weight on the instantaneous utility, but discount factors may depend on time, satisfies unanimity, then it is weighted utilitarian. So in particular, it is present bias if it doesn't weigh only the utility of one individual, if it's not effectively dictatorial. Okay? So if you just want this separability, then you're gonna get present bias. Okay? So I'm gonna skip the intuition for this. Okay, so the last thing I want to mention very briefly is what happens with voting. So I'm going to show you that voting might not work as well as one would want. And why are we even interested in voting? Well, initially we thought, well, maybe voting is just a way to pick up the dictator, the so-called dictator. It might be the case that if you use voting, the pivotal voter is essentially the voter that this collective utility mimics, right? So it would do really, really well. So now we're going to rank C and C prime by voting. As I talk through it, just think about simple majority. Okay, I'm going to give you a slightly more general result, but you can think about simple majority. Okay? And we want to know whether we can find sort of a representative voter. So say with the median discount factor. And we, in particular, we want to know whether this ranking is going to be rational and, for example, transitive. Now notice that here we're going to get something that's very similar to the Arovian types of result, because essentially there are three types of dimensions to decisions that are playing a role here when we're thinking about decisions between streams. First of all, there's the short-term consumption. If you think about very impatient individuals, they care about the immediate consumption. Then incredibly patient individuals care about overall consumption. So they care about kind of the sum of consumption in some sense, if you look at very patient individuals. Whereas moderate individuals may care about the distribution of consumption across time. So there are these three types of dimensions of consumption streams that different discount factor agents may worry about. And this is what's going to be at the root of a result that's essentially an Arovian result. So we're going to say that R is a voting rule, again, keep in mind majority, if it only depends on information regarding who prefers one alternative to another. So essentially, you're ignoring cardinal differences. You're taking into account only ordinal preferences. This is what identifies a voting rule for us. So specifically, it will capture any weighted majorities, supermajorities, kind of the stuff we like. Now, a voting rule is locally non-dictatorial if it never picks in favor of one agent's ranking when everyone else has the opposing ranking. Okay, so we're going to focus on non-dictatorial rules. Again, think of majority, that satisfies that. Okay. So now let's assume that all agents have strictly concave utilities. If a voting rule is locally non-dictatorial, it never kind of follows the preference of one agent when everyone else opposes, then it is intransitive for some profiles of discount factors. Okay. And this is rather strong in the sense that you need to restrict consumption streams a fair bit in order to rule out this result. So even if we look at kind of normal budget set restrictions of consumption streams, you'd still get this sort of result. Okay. So, any questions? Yeah.
So is that the same as no equal?
Yeah, I guess so. Yeah, that's a good point. Yeah.
Just one agent.
Yeah, where. But the only thing is that you don't fix this agent, so no agent has veto power.
Right.
Yeah. Exactly.
They're all I.
Exactly. Yeah.
It's your minimum democracy. But this is if I go back to Boylan, they didn't do it generally at all. There's voting. In pure majority voting, they've got voting over infinite streams of consumption, and they get, there's an example of this.
Right.
But they get the intransitivity precisely those three classes of people.
Right.
But this is
Yes.
So just to make sure I understand. So basically, the set of all sequences of consumptions is sufficient to reach for
Exactly. Exactly.
So what happens is if you only restrict yourself to say increasing parts of consumption or only decreasing parts of consumption.
Yeah, so you need some restriction that's very similar to increasing consumption path in order to rule these sorts of effects.
They would rule them out.
Exactly. Yeah. And differences.
What if everybody's, what if this is the completely flat one? Where the outcome is always.
So that would be rule of the out.
Oh, yeah, okay.
Yeah, I think the local, yeah. Okay. So, other questions? Okay. So as a summary, what I tried to show you is that utilitarian aggregation always leads to a present bias. Any non-dictatorial and unanimous collective utility function is time inconsistent. So in a sense, whenever you're aggregating individuals who have some difference in time preferences, time inconsistency is par for the course. And voting rules aren't necessarily intransitive. Now, if I had more time, I would show you some experiments that we've done that are related to that, where we try to elicit subjects' kind of social preferences. So we basically put them in the same environment that our agents are in the theoretical setting. And so that allowed us to get some insight into planners' preferences. And what we saw is that the experimental planners put a lot of weight on utilitarian and egalitarian motives, which ended up leading to a lot of present bias. So when we looked at these sorts of preferences in the lab, we saw that they were putting high weight on utilitarian motives, which ended up producing a lot of present bias in lab observations as well. And that's all, folks.
When you say in transit, he'll talk about it.